Hello students, in this video we are going to discuss about Archimedes Principle. You all might have studied in junior classes about something called Eureka, where Archimedes was taking bath in a big tub, right? And he was taking bath and he was inside the water. That time he saw the overflowing of water. And suddenly it struck him some idea where the king has asked Archimedes to find out whether the crown made by the goldsmith was made up of pure gold. The king had a doubt whether the crown he has made, I am not able to draw properly, okay, let me say, the crown which has been made, right, is it made up of pure gold or is it mixed with some other metal? And Archimedes was his friend and philosopher, so he asked him, you find out. Then Archimedes was taking bath as the story goes, and when he was merged in the water, suddenly he found that the flowing of water was taking place. Something came into his mind, he did some calculation and he was able to find a way in which that it will be made up of pure gold or not. So again the story goes, he ran naked in the streets and shouting, Eureka, Eureka, Eureka. And Eureka means I found it, I found it, I found it. So now today we are going to discuss about the Archimedes Principle. And also the word equally we study is buoyancy. Buoyancy, you might have heard life buoy. From there the word is buoyancy, B-U-O-Y-A-N-C. We will learn about that also. Right. So let me move into the concept of Archimedes Principle. Again, it's all very simple, basic concepts. Right. See, when you take a container and fill it with water. Okay. Fill it with water. Now, when you take, for example, a mug, in the morning when we take bath or something, you take a plastic mug and try to push the mug down into this water, right? You'll find that the mug will be coming up, bouncing back, right? There is a force acting in the upward direction, and that is called upthrust. That is referred to as upthrust, and also you can call it as buoyancy. Buoyancy is nothing but upthrust. And what is upthrust? Force exerted by the liquid on the object. Now what Archimedes is saying, that principle, what is it going to be? We are going to connect now buoyancy, upthrust with the weight of the body. Okay, fine. So what we do, we take a can. We take a can, fine. And it has a nozzle here. This is referred to as Eureka can. Eureka can. Now what we do, we fill it here till this point. Okay, till this point we fill it with water. Okay. Now after that, we take, for example, a stone, you can take it. Tie it with a thread. Okay, tie it with the thread. Now, you can suspend it with a hand in the initial stage. Later, you can use a stand also to do that. You can have a retort stand, and we can, if you want, for example, more precisely, I will draw a retort stand here. Okay, and you can hang it like this. Okay, so you will be able to bring it down. You know, there will be movement here. You can take it like this, fine. Yes, and you can bring it down, lower it down. When I immerse this stone, right, and immerse it inside, what will happen? The water will come out of the nozzle. Let me collect this in a beaker, a small beaker, right? You will find that the water has come down. Yes, the water will drip down and it will come down like this. It will be coming out like this. One thing we should remember, what is the volume of the stone will be equal to volume of the liquid displaced. Volume of the liquid displaced, that is water displaced. Okay, so this is very simple. If the volume is space occupied, if the volume is, let us say, 100 cubic centimeter, and you will find that 100 cubic centimeter will be displaced, and 1 cubic centimeter is 1 milliliter, so that is equal to 100 ml water will come out. This is very simple. Now what Archimedes principle is saying, it is not talking about the volume. We know the volume displaced is same. That is we accept it. There is no doubt about that. It's very straight conclusion. Okay. Now what Archimedes principle says, whenever a body is immersed partially or wholly. See, for example, when I take the beaker and there is water in this, right? And when I immerse a stone, let us say a body, partially or wholly, I immerse it partially or wholly, an upward thrust is acting. That's very simple again. Yeah, an upward thrust is acting, which is called buoyant force, or buoyancy, or buoyant force. So buoyant force is equal to upthrust. We know that. That will be equal to the weight of the liquid displaced. Come on. Again I state the term here, right? Let us keep a nozzle here and let the water be filled here. Okay. And what it says, this will be equal to weight of the liquid displaced. Weight is different to volume. You should remember that. Okay, the upthrust, the upward force is acting. So water is coming out, and the weight of the water, you find the weight of the water. What is weight of the water? Mass into acceleration due to gravity. You find the mass of this water, and then you multiply with the acceleration due to gravity. That will give you the weight of the water. So buoyant force is equal to weight of the water displaced. This is called Archimedes principle. Again, let me state it for you, right? When your body is partially or wholly immersed in a liquid, it experiences an upward thrust called buoyant force, which is equal to the weight of the liquid displaced by the body. We can prove this actually. I am going to show you the proof of Archimedes principle, which I am going to discuss now. Okay, so how can we prove this mathematically, right? Then we will feel comfortable and we will be able to accept the concept of Archimedes principle. So let me take it now. We need to prove that upward thrust is equal to the weight of the liquid displaced. This is what we need to do it. Okay, so how can we do this? Simple. Let us take, for example, a vessel. Let us take in this vessel, okay, let me take a vessel and let me fill with water. Okay, now a body is going to be immersed. Let us immerse a body. Okay, this is the body I am immersing. Let me draw it with the 3 dimension. Okay, so this is how I get the body, right? This is the body. Let us say the height of the body is h, and the area of the body which I am saying, you can imagine the duster. This is the body, right? But it is not wood here, it is some other body, it is going inside, right? It is inside. Now, the area is A. Let us say it is lying at a distance x from the surface of the liquid. So this is the whole thing is water. Very simple, we can take a water, we can take and do this experiment, right? So this is going to be. Now, this point is, there is a pressure P1 and there is a pressure here P2. You know that the pressure at this point P1 and pressure at the point P2. We know that the force is acting upward direction. The upward thrust is acting. The thrust is acting in the upward direction. The resultant force is in the upward direction. So keeping this in the mind, now we will discuss and derive. So let us say, what is pressure 1? Pressure 1. We know pressure is equal to, in a liquid column, H rho G. So the density of the liquid we have taken is rho, G is acceleration due to gravity. So P1 is equal to H rho G. But what is this H here? This is the liquid column above, right? This is falling at a distance x. So instead of H rho G, we write X rho G. Call this as equation number 1. Now what is the pressure at this point 2? Pressure at 2 is equal to again H rho G. I am writing a straight equation. But what is this H here? Not only this H, the height of the liquid column, it is not only the height and also the height above from the surface we are measuring. So I will write here X plus H rho G. This is equation number 2. I hope you understand. First point is pressure at this point P1 is due to the liquid X, and pressure 2 at this point is due to X plus the object we have taken H. So X plus H rho G. So now what is the difference in pressure? That is P2 minus P1. You should keep it in mind. Pressure changes with the depth. At the lower depth, it will be having more pressure. So P2 minus P1, that is equal to X plus H of rho G minus X rho G. That is equal to X rho G plus H rho G minus X rho G. So X rho G plus and minus gets cancelled. So I have H rho G, that is change in pressure P2 minus P1. You get this point? H rho G is the difference in pressure P2 minus P1. Now we know that there is an upward thrust. The force is acting in the upward direction, right? We know that pressure is equal to force upon area, right? From this I can say force acting in the upward direction, that is equal to up thrust is equal to P into A. Okay, so let me erase this part now and take this to the main area. Okay, so again let me state here, pressure is equal to force upon area, which implies that force is equal to pressure into area. Now we want to know this pressure force which is in upward direction, that's why it is pulling water is being displaced now. Okay, this is equal to pressure into area. This is nothing but difference in pressure into area, or I can write it more better, P2 minus P1 into A. That is a pressure acting which is pushing it outward, right? So let me remove this part now, right? What is P2 minus P1? That is equal to H rho G into area. So we know that from all this discussion that the upthrust is equal to H rho G into area. What are we trying to prove? We are trying to prove that the upthrust acting is equal to, if suppose if I have a nozzle here and I take the water out in a beaker and the water is falling here and I collect it in this beaker, I have to prove that this upthrust is equal to the weight of the liquid displaced. That is what Archimedes Principle is saying. Okay, so now what is area into height? I said to you before also, volume is equal to area into height, because L into B into H. This LB is nothing but area. So volume is equal to area into height. So that is equal to, I can write V rho G. I can write it as V rho G. What is V rho G? Upthrust. Now again we come to one more step. We know that density is equal to mass upon volume. Okay, now I can say that density, instead of density I have substituted mass upon volume, and I will write here mass upon volume into G. Volume gets cancelled. So again you will say that upthrust is equal to M into G. What is M into G? Mass into acceleration due to gravity. That is weight of the liquid displaced. What has been displaced here? Weight of the liquid, right? Rho is the density of the liquid. Okay, so V is volume. Volumes are same. I said volume of the block and volume of the liquid displaced, they are one and the same. So naturally we prove that the upthrust is equal to upthrust is equal to the weight of the liquid displaced. Okay, so this is actually the proof of Archimedes principle. Okay, I hope dear students you understand what we try to do. Yes, I would like to do a practical, and I will shoot a practical in the lab, and also I will show you how exactly they all fit in the perfect way, right? If it is 100 Newton, 100 Newton. Okay, so here I want to say a particular point to you. Yes, first let me complete Archimedes principle. So again I state Archimedes principle. Archimedes principle states that when a body is partially or wholly immersed in a liquid, it experiences an upthrust called buoyant force, which is equal to the weight of the liquid displaced by the body. So this is the statement. So now a small extension of it, you try to answer this. Yeah, this is the discussion derivation. As I said to you, any book you can read, don't worry, any particular book, right? I may use one particular book. You can use ABC, modern physics, you can use Pradeep physics, or you can use Newton physics, any book. Yeah, they are all same, concept is same, it cannot change. For example, if I take a beaker and I fill it with water, and I take a spring balance, okay, I take a spring balance, okay, and I hang a, let us say, stone, right? When you find out what is the weight of the stone or mass of the stone, because no, the spring balance can be graduated so that it measures the mass. If the mass or weight of the stone in air is equal to 100 gram. 100 gram. When I immerse it in water, when I immerse this in water, will the weight again I cannot use the word mass. Mass does not change. Mass remains the same. The weight only varies. What will be the weight? Will the weight will be, let us say, 90 grams? Will it decrease? Or will it be 110 grams? What will happen? Will it be less or will it be more? Think of it, connect with upthrust, buoyant force, and then try to answer in your comments section. Will it be approximately 90, less than 100 gram or more than 100 gram? Try to find out. You can just easily answer this question. Okay, in the next section we will come with the next concept, and for now, thank you so much.